In this course, you will master the essentials of TypeScript. TypeScript is a powerful, statically typed superset of JavaScript that helps you write safer and more maintainable code. In just 1 hour, you'll learn everything from basic types and annotations to advanced features like generics and interfaces. The course walks through practical examples, helping you understand how TypeScript can make your code more robust, maintainable, and error-free. Each section is structured to build your knowledge step by step, so you can follow along and code in real time. And by the end, you'll have a solid foundation in TypeScript and the confidence to use it in your own projects. Muhammad from Glitchy Devs created this course.
TypeScript is JavaScript with syntax for types. It is all about type safety. Sometimes JavaScript exhibits unexpected behavior. For example, if you write 2 plus 2, it will return 22. However, with TypeScript, all of these problems just disappear. TypeScript is a programming language built on top of JavaScript. It enhances JavaScript by offering several features that aid in creating more robust and maintainable application while reducing development time. The most significant feature TypeScript provides is static typing. Static typing, a core concept in TypeScript, it's what sets it apart in programming. We have two categories, statically typed languages and dynamically typed languages. Statically typed language like C++, C#, Java, require declaring a variable's type at compile time or during coding. For example, a variable can be declared as an integer and it can only store integer values. This fixed type prevents the variable from holding string or any other data type, making the code safer and less prone to error. Dynamically typed languages like JavaScript, Python, Ruby allow variables to have dynamic types determined at runtime and changeable during execution. While this dynamic nature provides flexibility, it can lead to error. For instance, changing variable from number to a string later in the code may lead to unexpected behavior or crashes. This is where TypeScript comes in. TypeScript is JavaScript with type checking. It requires developers to explicitly specify variables type. Similar to statically typed languages, the TypeScript compiler checks your code for type-related error at compile time, catching many issues before runtime even. This helps you to identify and resolve error early in the development process. You can use TypeScript in a lot of domains, from front-end development to back-end development, and more. Why should you even learn TypeScript? Well, high industry demand, making it valuable skill in the job market. As you know, JavaScript can be as complex as quantum mechanics, but TypeScript simplifies it and make it more reliable. Efficiency. TypeScript reduced the need for unit testing and saving a lot of time. Error prevention and quick feedback. TypeScript detects error before runtime even, providing instant feedback for faster and more reliable development. Seamless integration. It seamlessly integrates with JavaScript, making adoption painless. Framework empowerment. TypeScript enhances popular frameworks like React, Vue, and Angular with advanced features such as interface. In this tutorial, I will explain TypeScript as simple as I can, with animation and fun way. So happy tutorial hell. How TypeScript works. TypeScript compiler compile TS code into JavaScript code. This is called transpilation. To follow along with this course, you only need to have basic knowledge of JavaScript and cup of coffee. Alright, now let's talk about the setup. First, install Git, download Git from official website, Git downloads. Install Visual Studio Code, download VS Code from the official website, VS Code downloads. Install Node.js, download Node.js from the official website, Node.js downloads. Choose the LTS, long time support version. for stability. Follow the installation instruction for your specific operating system. Verify Node.js installation. Open your Git patch. Run the following command to check if Node.js installed. Node-v. It should display the Node version if it's installed correctly. Once Node.js is installed, you can use the Node.js package manager npm to install TypeScript globally. Open your Git patch. Run the following command to install TypeScript. npm install -g TypeScript. After installation, verify TypeScript by running tsc-v. It should display the TypeScript version if it's installed correctly. Now we'll start with some action. Create your first application. But before we start, I will mention that you can find all the code in the description. Now let's get started. Create a new folder on your desktop, for example, named TypeScript. Inside the TypeScript folder, create a new file called index.ts and open it in VS Code. Write the following code in index.ts. console.log math.floor. Notice that VS Code highlights math.floor as if there is a problem even before compiling or running the code. If you hover over it, it will see the message expected one argument but got 0. See, this is what I was talking about. To fix the problem, add number. In this case, I will add 11.3 as an argument inside math.floor. And congratulations, you have created your first application. But to run this application, well, now we're talking. Let's start running our application. Open the Git bash and navigate to the directory where you created your TypeScript file on the desktop. In this example, because I created TypeScript folder in my desktop, this will make me access the TypeScript folder. Step 2. Compile TypeScript code to JavaScript. Use the tsc command to compile into JavaScript. That will generate a JavaScript file with the same name as your TypeScript file, index.js. Run the JavaScript file. Once the TypeScript file is compiled, you can run the resulting JavaScript file using Node.js. For example, node filename.js. In this case, node index.js. This will execute your JavaScript code and you should see the output in the Git patch. And now let's dive into the configuration. Let's begin by structuring the project. Create source file, CRC. Move the index.ts into it. Generate tscconfig.json file. Create a tscconfig.json file with default setting using this command tsc-inet, which is stand for initialize. This command will generate tsconfig.json file in your project directory, including default compiler options. Customize tsconfig.json. Open tsconfig.json file in a text editor, VS Code. You will see a lot of configuration options. In this tutorial, I will focus on two things. The first thing is root dir, output inside its source. Root dir define the root directory for TypeScript source file, and out dir, output inside it dest. The out dir specifies the output directory for compiled JavaScript files are going to be generated. Now, save config.json, save your changes, compile your TypeScript code. After creating and configuring tsconfig.json, compile your TypeScript code by running tsc. TypeScript will utilize the setting defined in your tsconfig.json to compile your code. Run the compiled code. Once your TypeScript code is compiled to JavaScript, you can run the compiled JavaScript file using Node.js. Use the following command, node dest/filename.js. In this case, node dest index.js. This will execute your JavaScript code and you should see the output in the terminal. While JavaScript comes with built-in types such as numbers, strings, booleans, null, undefined, and object, TypeScript takes it a step farther by extending this list and introducing several new types. TypeScript introduces types like any, unknown, never, enum, and tuple to provide developers with a more versatile and robust type system. Type annotation in TypeScript. Type annotation are used to especially specify the type of a variable, function, or any other entity. This helps the TypeScript compiler to understand and enforces you intend to use in your program. Type annotation are typically added using a colon followed by type. Using type annotation with variables, you can explicitly annotate variable types in the following way. In this example, my number is explicitly annotated with type number and my string is annotated with type string. This makes it clear to both developers and TypeScript compiler what types is these variables should hold. Can help catch potential type-related issues during development as follows. In this alternative approach, you first declare the variable and then assign value to them later. TypeScript still understands the type based on initial declaration, provide the same level of type safety and code clarity. By using type annotations, you ensure that your code is more robust, manageable, and less error-prone, making it easier to work on large projects and collaborate with other developers. Dynamic type determination. If you choose not to use type annotation in TypeScript, the language can still figure out the type dynamically based on your declaration. For instance, this example, TypeScript will automatically infer the type of variable greeting as a string. However, while TypeScript can infer type, it is generally not recommended, as it may lead to unexpected issues. Defining types through type annotation is best practice. AnyType. Now, regarding the AnyType is a special type in TypeScript that can represent any type of value. When a variable is assigned to any type, it essentially tells the TypeScript compiler to disable type checking for that variable, allowing it to hold values for any type. Here is an example of any type. In this case, my variable can assign to a number, string, or any other type without any checking. However, it's generally advised to avoid using the any type whenever it's possible. It's for this following reason. Load the type safety. Reducing code reliability will make it less maintainable. Type annotation with objects. Type annotation with objects in TypeScript allow you to specify the types of properties that an object should have. We have this first example, and you can write it in the other method. We're defining an object named person example2 with specific type annotation for its properties. Name, it's required to be string property. Age, it's required a number property. Job title, it is optional string property indicated with job title. Address is an object with two required property, street, string, and city. We initialize person2 with specific value string. Address is an object with two required property, string, street, string, and city string. We initialize person example2 with the specific values for each property later in this code. Function. Type annotation with function. Type annotation in TypeScript are used to explicitly specify the data types for function parameters and return values. These annotations help both developers and the TypeScript compiler understand and enforces the expected types of values that function should accept as argument and return as result. Type annotation for function are typically added using colons within the function parameter list and after the parameter list to denote the return type. Here is a simple example illustrating type annotation with function. In received examples, we define a function, calculate react angle area, that takes two parameters, length of react angle and width of react angle, and use type annotation to specify that both parameters should be number. Additionally, we specify that the function should return a value of type number by using colon number after parameter list. We calculate the area of react angle by multiply the length angle and the width of react angle parameter and return the result. We call the function with valid arguments, length and width, which both numbers. We store the result for the function call in variable named area and lock the calculated area to the console. In TypeScript, you can make function parameters optional or provide default values to parameters, allowing for more flexible. This feature is especially useful when you have functions that can accept a varying numbers or arguments, or when you want to provide default values in case the color does not supply the particular argument. Let's break down optional and default parameters. An optional parameter is one that may or may not be provided when calling the function. To define an optional parameter, you can use simple after the parameter name in the function parameter list. The TypeScript compiler allows you call a function with or without providing value for optional parameter. Default parameter. A default parameter is a parameter that automatically takes a default value if no argument is provided during the function call. To set a default value parameter, you can use equals operator in the parameter list example. In the example, the age parameter is optional. In the first case, using optional and default parameters in your function give you greater flexibility when designing your function interface, allowing callers to provide only the information they have while ensuring a smooth execution of your code. This feature is valuable for creating functions of various requirements. Function rest parameter in TypeScript as well as in JavaScript. A rest parameter allows function to identify number of argument as an array. This means that you can pass any number of arguments to function and they will be collected into an array which can be accessed within the function. Rest parameters are specified using spread operator, 3 dots followed by the parameter name in the function parameter list. In this code, the add all function is defined with rest parameter nums, which is capture a variable numbers of numeric arguments and store them in array named nums. The type annotation number square brackets specified that the element in nums array should be type numbers. Inside the function, a for loop is used to iterate through the nums array and calculate the sum of the numbers provides arguments of all the numbers provided as arguments. Protect plus true in JavaScript is an unary plus operator applied to Boolean true, resulting the numeric value 1. An arrow function in TypeScript is a way to define function using more compact syntax. The add with arrow variable is assigned arrow function that perform same additional operator. An anonymous function in TypeScript and in JavaScript is a function that does not have name. And instead of declaring named function, you define functions directory as an expression. They are particularly useful when you need small one-off function without polluting the global scope with function name. The add variable is assigned an anonymous function that adds two numbers, num1 and num2. Void and never. In TypeScript, void and never are two types that represent different concepts. 1. Void type. The void type is used to indicate the absence of a value. It represents a function that do not return any value or return identified. It's often used to annotate functions that perform action or side effects but don't produce a meaningful result that's need to be assigned or captured. The never type is used to represent values that never occur. It's typically associated with functions that never return, either because they throw exceptions, entire and infinity loops, or have unreachable code. Example: in the throw error function, it throw error and never return normally. In this infinite loop function, it unturns an infinite loop and never exist, resulting a never return type. Union types. Annotating a variable with union types mean specifying that the variable can hold values of multiple types. Union types in TypeScript are denoted using the pi symbol between the types. For example, in this code, my var is annotated with union types, string, number, which means it can hold either string or number values. You can assign values of either types without causing type error. However, if you try to assign a value of a different type, like a boolean for example, TypeScript will report a type error because it's not part of the specified union type. Literal type are a type system feature in TypeScript that allow you to specify exactly which values are allowed for a particular variable or function parameter. And instead of using general type like string or number, you can specify a literal type that can only take on a specific value. For example, you can define a literal type like this: let direction, left or right or up or down. In this case, direction variable can only be assigned one of the four literal string values. In this case, the direction variable can only be assigned one of the four literal string values: left, right, up, or down. Any other value would result a type error. Literal types are especially useful in scenarios where you want to be very explicit about the allowed values or a variable parameter or property. They provide a level of type safety by ensuring that the only specific values are accepted, which can help catch errors at compile time rather than runtime. Here is an example. In this case, the color parameter can only be one of three specified string letters: red, green, or blue. This helps prevent potential bugs by restricting the input to predefined set of values. Literal type can be combined with other TypeScript features like union types, instructions type, and more. Create powerful and expressive type definition in your code. Nullable types. Nullable types in TypeScript allow a variable or parameter to have either specific data type like string or number or special value none. This feature is useful for scenarios where a value might be absent or undefined, and you want to explicitly account for that possibility in your type annotation. In TypeScript, you can create nullable type by appending null to an existing data type. In this example, username can either store a string or null, while age can either store a number or null. Nullable types are helpful when working with data that may not always be present or initialized. They make it clear in the type system that variable might have in the value null, which can help prevent runtime errors caused by trying to access properties or method on a null value. Here is an example of using nullable types with function parameters. In this function, username is defined as nullable string, so it can accept either string or null. The function handles both cases, providing a default greeting for guests when username is null. Nullable types help improve code safety and clarity by explicitly inducting the possibility of missing or undefined data. However, developers should be cautious when using nullable types to avoid unnecessary null checks and ensure proper handling of null values in their code. A type alias in TypeScript allows you to create custom name for type. It is a way to define your own custom data type that can be compressed of existing types like numbers, string, objects, or other custom types. Type aliases provide improved readability, maintainability, and traceability for complex type definition. In this code, myString is a type alias for a string type. MyString or number is type alias for union type that can be either string or a number. We then declare variables myName and myValue using these type alias to assign value that specifies type. Let's explore another example, this time using a type alias with objects. Type person. In this example, we define a type alias employee for an object with three properties: name, a required string, age, a required number, and email, an optional string. We then create two objects, Alice and Bob. Using this employee type alias, Alice includes all the three properties while Bob omits the optional email property. Type aliases provide way to define complex object structure with specified types and trace them throughout your code, improving code readability and maintainability. Intersection type. An intersection type in TypeScript allow you to combine multiple types into one, creating a new type that has all properties and functionalities of the individual types being intersected. Here is a simple example to illustrate. In this example, we have two types, first type and second type. We then create a new type called combined type by using AND intersection operator, which combines the properties of both first type and second type. The combined type includes all properties from both types, allowing you to use them together. Type annotation with arrays allow you to specify the expected data type of the array elements, ensuring type safety in your code. In this example, we annotate the fruits array as an array of string. We use a for loop to iterate over it, displaying each fruits in uppercase letter. Type annotation with multidimensional arrays. In this code, array 1 declare as an array of numbers. Annotate with type number. This means it can only contain a numeric type. Array 2 is declared an array string. Annotate with string array type. It should only contain a string value. Array 3 is declared as an array that can hold elements of either type, string or number. Annotate with string number array. This array allows for mixture of numeric and string values within the same array. Tuple is a data type in TypeScript that is similar to an array, but it has fixed number of elements, and you can specify the types of each element at specific position. Within Tuple, we define a tuple type for article variable, specifying that it should have three elements with a specific type, number, a string, and boolean. We assign matching tuple value to article. We demonstrate that you can reassign a new tuple values that matches the type structure. We show that tuples are fixed in size and can't have additional elements added. Lastly, we used the struct tree to extract and display the individual elements of article tuples. Enums in TypeScript are a way to define a set of named constant values representing discrete options or categories. They provide a convenient means to work with descriptive values in a more readable and expressive way. Enums allow you to create new data type composed of predefined related values. Here is an example of how to define and use enum in TypeScript. In this example, we create an enum called days with a list of constant values starting starting from 0 by default. Enums allow you to assign meaningful names to these values. We assign the value days.wednesday to the variable today. We use days today to retrieve and display the name of the day associated with the value in today. Enums make code more readable by providing human-readable names for specific values, and they are commonly used for categories like days of the week and status codes. Interface. An interface in TypeScript is a way to define construct or blueprint for the shape and structure of an object. It specifies the properties, method, and their types that objects. Implementing the interface should have an interface defines a set of rules that an object must follow to be considered valid according to that interface. Shape definition. Interfaces specify object structure, including property, names, types, and optional required status. Contract. Objects or classes adhering to an interface must implement defining structure and method. Type checking. TypeScript checks if object meet an interface requirements, catching type errors early. Code clarify. Interface document expected object properties and enhance code readability, aiding object usage understanding. Here is a basic example of interface definition. In this example, we define an interface person example 1 with two properties, name, a string, and age, a number. We then create an object, Alias, that adheres to this interface. Interfaces are widely used in TypeScript for defining the structure of data objects, specify the shape of function parameter, and return values, enforcing consistency in class definition, code maintainability, and collaboration. Interface, method, and parameters. In TypeScript, an interface can define not only the structure of an object, but also the signature of function or methods that object adhering to the interface should have. This allows you to specify not just properties, but also the method and their parameters and return types that should be present in object implementing the interface. In this example, interface declaration, we define an interface named person example 2 with three numbers, name, a property type string, age, a property type number, greet, a method that takes parameter of type string and return void, inducting that it does not return any value. It just print hello TypeScript. Object creation. We create an object Alias that adheres to person example 2 interface. It has properties, name, and age as well as a greet method that takes a message and logs it to the console. Method invocation. We call greet method on the Alias object passing in a message. The method uses object properties to construct greeting message and logs it to the console. Reopen the interface and use cases. Interface reopening in TypeScript is a valuable technique for building and expanding interface as your project grows. Promoting modularity and code organization, it enables you to create versatile, flexible, and constant object structures. In this example, interface declaration, we start by defining an initial interface called setting for the home page, which includes properties like theme and font. The theme property is read-only interface. Interface reopening. Article page, we reopen the setting interface to add a sidebar property specific to the articles page. This demonstrates how interface can be extended as different parts of the application require additional properties. Interface reopening. Contact page. The setting interface is reopened again, this time for the contact page, where an external property is introduced. Object creation. We create an object named userSetting that compiles with the merged setting interface, including properties from all interface, declaration, theme, font, sidebar, and external. This object represents userSetting incorporating attributes from different parts of website. Let's talk about the use cases now. Modular development. Interface reopening enables modular development, allowing different parts of project to contribute interface definition. Each section forces on specific properties prompting code organization. Progressive enhancement. As your application evolves, you can extend interfaces to accommodate a new feature or setting. This incremental approach ensures backward compatibility and code flexibility. Clear separation concerns. Interface reopening maintains a clear separation of concerns between different sections or modules of your application while ensuring a constant data structure. Built-in interface. In TypeScript, a built-in interface refers to an interface that's predefined and provided by TypeScript language or underlying JavaScript runtime environment. These interfaces define the shape of behavior of objects or values for specific use cases and are used to ensure type safety and compatibility in TypeScript code. Examples of built-in interface in TypeScript include HTML element interface. TypeScript provide built-in interface for HTML elements such as HTML element, HTML dev element, HTML anchor element. These interfaces define the properties and method available for working with elements in documents object module DOM. Now, let's talk about one more example. HTMLImageElement. In TypeScript, HTMLImageElement is a built-in interface that represents an HTML image element. This interface extends the HTML element interface and providing additional properties and methods specifically related to the image. Here are some of properties and methods you can access when working with HTML image elements. Let's talk about the properties. Alt, a string representing the alternative text for image. Height, the height of the image in a pixel. Source, the source URL of the image. Width, the width of the image in pixels. Method, complete, a Boolean values, inducting whether the image has finished loading. Decode promise, a method that returns promises and evolve once the image is decoded. Natural height, the intrinsic height of the image in pixel. Natural width, the intrinsic width of image in pixel. By using the HTMLImageElement interface in TypeScript, you can access and manipulate properties and methods related to image elements in type-safe manner when you're working with document object model DOM in web application. This helps you catch potential errors and provides better code assistance in modern code editor. Example of using HTML image in TypeScript. In this example, we create an HTML image element set of properties and work with the sum of its method in TypeScript constant. Interface with type leases. In TypeScript, both interfaces and type leases serve similar purposes, defining custom data structure and types. However, they have some difference in terms of usage and capabilities. Here is a comparison between interface and type leases. Declaration syntax. Interface declared using the interface keyword. Type leases declared using a type keyword. Extending and implementing. Interface can be extended by other interfaces using extend keyword and implementing by class using implements keyword. Type leases cannot be extended or implemented directly. However, you can achieve similar results using instruction types. Compatibility. Interface supports a declaration merging. When you declare multiple interfaces with the same name, TypeScript will merge them into single interface. Type Alias does not support declaration merging. If you declare multiple type Aliases with the same name, you will get an error. Extensibility. Interface used when you need to define the shape of object and also when you need to implement them in classes. They are more suitable for defining constructs that classes must adhere to. Type Alias used when you want to create custom type that can be combined using union types, instruction types, or when defining complex types. Readability and style. Interface preferred when defining shapes of objects, especially for public APIs, as they convey an intent clearly. They also work well with code editors, IntelliSense for auto-completion and documentation generation. Type Alias, useful for defining union instruction and more complex types. They are often used to give descriptive names or specific combinations of types. In most cases, the choice between interface and type aliases depends on your specific use case and coding style. Both are valuable tools in TypeScript for defining custom styles and enhancing code readability and maintainability. In TypeScript, a class is a blueprint for creating objects with shared properties and methods. It helps in defining and organizing the structure of objects in your code. In TypeScript, class type annotation are used to specify the types of properties, method, and constructs parameter within the class. They define the expected data type and enable TypeScript to perform type checking to ensure that the class instances adhere to the defined structure. Class-typed annotation help catch type-related errors at compile time, improving code readability. Here is an explanation of class-type annotation. In this example, class product defines properties ID, name, and price, each with type annotation specify their expected data types. The constructor of the product class takes three parameters, ID, name, and price, and their types are annotated with the getProductInfo method. Is defined with a return type annotation string to specify expected return time. An instance product1 of the product class is created and initialized with data. The getProductInfo method is called and product1 and the results is logged in the console. Class access modifiers are keywords used to control the visibility and accessibility of class members, properties, and methods. From outside the class, there are three main access modifiers. Public members declared as public are accessible from anywhere, both within and outside the class. This is default modifier if you don't explicitly specify one. As you can see, we can still get the name from outside the class. Private members declared as private are only accessible from within the class they are defined in. You cannot access private members from outside the class. As you can see, you cannot console.log a private member from outside the class. That's not gonna work. It's gonna make an error. But you can still log it inside the class. And here we have protected member declared as protected are accessible from within the class they defined in and from subclasses derived classes. You cannot access protected member from outside the class or unrelated classes. As you can sense, you can access the name from the parent class and from the child class, but you cannot get it from outside the class. These access modifiers helps you encapsulate the internal details of a class and provide a level of control over how class members are associated and manipulated. They are essential for maintainability, the integrity and security of your code in larger applications. Class accessors, also known as getters and setters, are ways to control access to the properties of class. They allow you to get and set the values of class properties while providing additional control and logic if needed. Accessors are defined using the get and set keyword, and here is an example. In this example, we have added a private property price to the product example Accessors class, which store a product price. Accessors get and set for the price property provided controlled access to price. The get method retrieves the price and the set method allows setting it while enforcing non-negative constraint. When the price property is set to a negative value, a message is logged to induct that is not allowed. The getProductInfo method still uses price to display the product price. We demonstrate using the setter to update the price and handle a case where invalid negative price attempted to be set. Class static members. Static member in class are properties or methods that belong to the class itself rather than to instances of classes. This means you can access them without creating an instance of the class. They are defined using the static keyword in TypeScript. In this case, the static member next ID is used to manage unique IDs for all instances of the product static member class. In this example, we have added a private static property next ID to the product class. This property keeps track of the next available ID for products. The generate next ID static method allows us to obtain the next ID in controlled manner and increments next ID for the next calls. When creating instances of the product's static member class, we use the static method product static members dot generate next ID to generate unique IDs for each product. Each product instance retains its unique ID and other properties. Class implement interface. The class ensures that it provides the properties and method required of that interface. It helps enforces constant structure for object created from that class. In this example, we have an interface, product implement interface, that define the structure of product within the properties, IDs, and names, as well as a method. The product class implements the product implement interface using the implement keyword. It provides the required properties, ID, and name, and method getProductInfo. Instances of the product class, product1 and product2, are created and assigned to variables of type product implement interface. This demonstrates that the class confirms the interface. Abstract classes and members. Abstract classes are used as blueprint for other classes. They cannot be instantiated on their own, but can be subclassed by other subclasses. Abstract classes can also contain abstract methods, which are declared but not implemented in the abstract classes itself. Subclasses are required to provide implementations for these abstract methods. Here is an example. Abstract item is an abstract class serving as blueprint for items. It includes a private static property next ID for generating unique IDs, a constructor initializing ID and name, a static method generate next ID for obtaining the next ID, an abstract method getItemInfo that must implemented by subclasses. Item is a concert class extending abstract class item. It provides a concrete implementation of getItemInfo. Two item instances, item 1 and item 2, are created with unique IDs and names. The getItemInfo method of each item is called displaying their information. Polymorphism is a concept in object-oriented programming that allows objects of different classes to be treated as objects of common superclasses. Method override is when subclasses provide specific implementation of method that is already defined, allowing the subclass to customize the behavior of that method. Don't be confused. I will explain to you in examples. This code example determines the concept of polymorphism and method override in TypeScript, which is commonly used in object-oriented programming. It defines abstract classes and concrete subclasses to illustrate these concepts. In this example, abstract class, abstract entity, define an abstract class named abstract entity which serves a blueprint for other classes. Features a private static property next ID to generate unique entity IDs. The constructor now uses protected instead of private for the name property to allow access in derived classes. Concrete subclasses, entity and another entity. To concrete subclasses extend abstract entity and another entity. Each class has its own constructor passing ID and name to the parent class constructor via super ID name. They override the getEntityInfo method to provide custom entity information. Usage of subclasses, instances of entity, and another entity are created and stored in the abstract class type abstract entity. The generateNextID method from the abstract class generates unique IDs. Polymorphism is demonstrated as the overridden getEntityInfo method are called on these instances even though they have an abstract class type. Console output, the getEntityInfo method is called on both instances, but the results are logged, showing different information based on the subclass implementation. This code illustrates polymorphism and method overriding. It enables the creation of various entity types while adhering to a common interface provided abstract class, showcase the power of object-oriented programming and inheritance. But what's the difference between class and interface? A class is for creating objects, while an interface is for defining the shape of the object. Generics. In TypeScript, generics are a feature that allows you to write reusable code by passing type as a parameter to another type, whether it's class, interface, or function. This means that you don't always have to specify type explicitly when you're writing code, as you can use generics to work flexibility with various types without resorting to using any type. The main advantage of using generics, including code reusability, you can use the same code with different types without rewriting it. Enhances safety. Generics helps detect potential errors compile time rather than runtime. Dealing with multiple types, generics allow you to work with a lot of types without specifying a particular type. Generics can be used in TypeScript to create generic classes, generic functions, generic interfaces, generic methods. As you see in this example, we define generic function, return type t, that takes the value of type t and return the same value of type t. That means we demonstrate using return type function with various types, including numbers, strings, booleans, and arrays. We specify type parameter t when calling return type function, allowing TypeScript to infer correct types for the returned value. The function provides type safety, ensuring that return value has the same type as the input value. Generics, multiple types. Generics in TypeScript can handle multiple types using union types or instruction type, allowing you to create flexible and versatile code that works with variety of data types. Let's break down these two approaches. In this code, return type example function, the return type arrow syntax, arrow function are generic functions that return the input value as they accept type parameter t and return a value type t. We demonstrate their usage with numbers and string. The test type function is generic function that takes a value and returns string describing the value and its type using the type of operator. The multiple type function is a generic function that accepts two values of potential different types, t and s, and returns a string combining both values. Each function demonstrates how generics can be used with different data types while manipulating type safety. Generic classes. Generics in classes allow you to create a flexible and reusable class structure that can work with variety of data types, ensuring code flexibility and type safety. In this example, we explore generics in classes using the user class as an example. In this example, we define generic class user t equals string, which allows us to create instances of the user class with different data types. The class takes type parameter t and by default it's set to a string if no type is provided. The constructor of the user class accepts an initial value of type t The show method of the user class takes a message of type T and displays it along with value property. This method demonstrates how generic class can work with type by the type parameter T. We create two instances of the user class, user1 with type parameter explicitly set to string, and user2 with type parameter set to number string. This showcases how the same class can be used with different data types while pre-saving type safety. Generics in interface allows us to create reusable and type-safe data structures that can work with different types, enhancing code flexibility and maintainability. In this example, demonstrated how collection class can be used with different item type while ensuring type safety. In this example, we explored the use of generics in classes and interfaces to create flexible collection class. We defined two interfaces, book and game, each representing different type item with specific properties. We create generic class collection T that allows us to create collection items of type T. The data property is an array for items, and the add method allows us to add items of types T to the collection. We create two instances of the collection class. Item 1 is an interface with the type parameter set to book, so it can only store objects that confirm the book interface. Item 2 is an instance with the type parameter set to game, so it's only store objects that confirm the game interface. We use the add method to add item of specified types to collection. Type assertions. Type assertions in TypeScript are a way to explicitly inform the TypeScript compiler about the expected type of a value, even when the compiler cannot determine it. Here is an example. We then have variable data of type any, which allows it to hold values of any type. We attempt to perform a type assertion, data as a string, to treat data as a string. In this case, we are telling TypeScript to trust that data is a string, even though it's not. Finally, we use repeat method, data as a string, to repeat the string 3 times and log it. Debugging. Alright, let's dive into debugging now. TypeScript application in VS Code. This skill is invaluable when troubleshooting issues and making sure our code behaves as expected. We'll break it down into few steps. 1. First, navigate to the tsconfig.json file. Go to the image section. Enable the source map feature. A source map is a file that helps map each line of TypeScript code its corresponding JavaScript code. This is primarily for debuggers and not mean for a human understanding. Step 2. After enabling source maps, recompile your code. You'll notice new files in your folder named fileexample.js.map. This is your source map files. Step 3. Let's make debugging more interactive. Open your file and add some logic. For instance, you can insert breakpoint by clicking on the line number. Breakpoints post code execution when reached. Step 4. Access the debug panel and create a launch.json file. From dropdown, select Node.js. This file configures VS Code for debugging. It specifies that we will use Node.js run and debug our program. 5. Add pre-launch task setting in launch.js. Set it to tsc build tsconfig.json. This tells VS Code to use the TypeScript compiler to build your application using specified configuration. 6. Now go back to your file.ts to start debugging. Open debug panel and click on launch program or use shortcut F5. 7. Your program start and execution health at breakpoint. In the debug panel, you have various tools. Step over F10, execute one line of code. Step into, useful for functions. Step out, useful for leaving function. Restart debugging section. Stop, terminate debugging. 8. On the left under variables, you can see detected variables as you step through the code. Watch these values changes If you don't see variable, you can add it to the watch window. 9. As an example, add console.log statement to see the effect during debugging. Start debugging session with F5 and use F10 to stop through line. Debugging in VS Code is a powerful tool to pinpoint issues and understand your code behavior step by step. Once you have done debugging, stop the debugging session. In this course, we have covered the fundamentals of TypeScript and most of what you will see most of the time. However, learning never ends, and there is always more you can explore and practice to become a TypeScript expert. So, what is next? Practice. The key mastering TypeScript or any language is practice. Start writing your code right now, implementing TypeScript. If you are working with JavaScript framework like React, Next.js, or others, start implementing TypeScript in your new projects. You will see how it improves code quality and helps catch error early. Explore other projects. Check out TypeScript in action by exploring open source projects in platforms like GitHub, GitLab. Analyze how experienced developers utilize TypeScript in their code. It's like reverse engineering, where you read code and figure out how things works. Documentation, of course. Dive into the official TypeScript documentation. It's a valuable resource that can provide in-depth knowledge and examples. Configuration. Dive into the TypeScript configuration files, tsconfig.json. Learn about various options and experimentations, and experiment with custom configurations to optimize TypeScript for your project. And now I can say congratulations to you for successfully completing this TypeScript course. Thank you so much for watching. Till the next time, stay curious and stay glitchy.